Hey guys, Mr. Adamson here. Welcome to another lesson where we're going to name and identify either ionic or molecular compounds. We are going to take a word equation and write it out in chemical form and balance it. And we're going to then identify what type of chemical reaction we actually have from our word equation. So the first thing we're going to do is identify what type of compounds we have here. And so if we go through, we have sodium chloride, we have zinc nitrate, sodium nitrate, and zinc chloride. So we can see with the first one here, with sodium chloride, we have Na, which is sodium, and we know that sodium has a 1 plus charge. We know that chloride is Cl, and it has a 1 minus charge, and we get all this information from our periodic table, of course. When we put those together, we cross-drop charges, and the superscript charge numbers up here become subscripts down here, and we drop the plus and minus signs, and therefore we have Na, and we don't actually have to write the ones because it's already understood that we do have one right here, so NaCl. So that is sodium chloride. And we can see that sodium is a metal, chloride, or chlorine, but when you write it out in a compound, you change the ending to "ide" of the anion, which is a nonmetal. So chlorine is a nonmetal. So we have a metal and a nonmetal together. Therefore, we know that is an ionic compound. Sorry for my writing here. I know it's kind of a little kiddish, but it's hard to stay neat on the iPad while I'm doing this. But however, the next one we have zinc nitrate. We know that zinc has a 2 plus charge, and we know that nitrate is a polyatomic ion. And the formula for nitrate, which is given to you in your data booklets, is NO3 1 minus. Again, cross drop the charges, put the subscript numbers in superscripts down here, and we get Zn. You don't have to write the 1 from the NO3. So we have NO3, and we have to take that 2 right here and put it down here, so 2. But we don't want to have 32 oxygens, we want to have 2 NO3s, so that's where we put the brackets around. So now we have 2 NO3s. And we know that we have a metal and zinc and a polyatomic ion here, which is 2 nonmetals together, and therefore we have a metal with nonmetals, and that gives us an ionic compound again. We look at the next one here, sodium nitrate. Sodium is Na 1 plus, nitrate again, NO3 1 minus. Put those together, cross drop charges, and we get NaNO3. Again, metal polyatomic ion, therefore we have an ionic compound again. And our last one here, zinc chloride. Zinc 2 plus, we get chloride 1 minus, cross drop the charges, and we would have Zn, don't have to write the 1 again, chloride, or Cl, and we put that 2 in subscript. We have a metal with a nonmetal, and we know that that is an ionic compound of a metal with a nonmetal, so ionic compound there. Now we need to take these formulas and write them out in an actual equation. So if I just delete that off of here, we get sodium chloride, so what we previously wrote, NaCl. Sodium chloride is ionic compound. We know from the properties of ionic compound they exist as solids for the most part. Reacts with plus sign zinc nitrate, and so therefore Zn NO3 2. Again, we have an ionic, so we're dealing with a solid. Sodium nitrate, NaNO3, solid, and zinc chloride, ZnCl, solid. So now what we need to do is balance. So we're going to split at our produce line here from our reactants to our products, and we're going to balance the sodiums first. And we can see we have 1 sodium here, so on our reactant side 1, we have 1 sodium here in our product side 1. Then we go to our chlorine. You can see that we have, I made a little mistake here. I forgot from previously writing this out that that zinc had a 2+ charge, so it was ZnCl2. So ZnCl2, and solid, of course. So we can see that we have 1 chlorine on our reactant side, however we have 2 chlorine on our product side. So what do we need to do? We need to put a big 2 in front of sodium chloride. So now that gives us 2 chloride on our reactant side here, because that big 2 applies to the whole compound. However, that affects our sodium, because before we had 1 and 1, now we have a 2 here. So if we have a 2 here, we need to have a 2 over here to give us 2 sodiums. Now our sodiums are balanced. So now we can go on to our zincs. And our zincs, we have 1 here and 1 here, because this subscript 2 only applies to what it's right beside. So 1 zinc, 1 zinc. Next thing we need to do is go to our nitrates, NO3, and we can see that we have 2 NO3. So this little 2 is going to apply to everything in the brackets, and because we have a nitrate on our reactant side and a nitrate over on our product side, we can count them as one whole entity. So we have 2 NO3s over here. Now with our NO3s on our product side, we already have a big 2 in front of this compound. And again, we know that the big 2 applies to everything in this compound, so that means we also have 2 NO3s. Therefore, we have a balanced equation. 2 sodiums, 2 sodiums, 2 chlorines because of this 2, 2 chlorines because of this 2, 1 Zn, 1 Zn, 2 NO3s because of this 2, and 2 NO3s because of this 2. Now we have 4 compounds here, and again, of our 5 types of reactions, we have formation, decomposition, hydrocarbon combustion, single replacement, and double replacement. Now we can see that we also have all ionic compounds where we have a metal and a non-metal together. And if we look here with sodium chloride, we don't have sodium chloride in our product side, but we can see sodium chloride and zinc nitrate, 2 totally different things, sodium nitrate now and zinc chloride. Our sodium with chloride here is with nitrate in our reactants, or in our product side. Therefore we have our metals switching places, because our zinc, which is with nitrate in our reactant side, is with chlorine on our product side to give us zinc chloride. Therefore we have 2 things switching places. That means that we have a double replacement reaction. And there we go. We have identified and named the compounds. So all ionic compounds. We've wrote out the word formula. We have balanced it in chemical formula now. And we have also called or named what type of reaction we have, being a double replacement. So hope you're able to learn something from that today. There's videos on formation reactions, decomposition, hydrocarbon combustion, single replacement. Please watch those if you need some more help. And thanks for listening.
Made with Doodlecast Pro.